In this series of videos, we are going to talk about permutations. And our goal with talking about permutations is to understand the mathematics that's presented in the episode of Futurama that you watched yesterday. So today we're going to cover the basics, and tomorrow we're going to actually go into the theorem itself, the Futurama theorem. So let's start with what is a permutation. It's simply an ordering of objects. And so if you want to think about the three fruits like apple, pear, and grape, and how many different orderings could you eat them? Well, you could eat the apple first, and then you have to decide, are you going to eat the pear next or the grape? Well, you could have eaten the pear first, and then you could go grape, then apple, or pear, apple, grape. These are just different orderings of the fruits. They're permutations of the fruits. You could have also eaten the grape first, and then you have to decide between the apple and the pear, and then eat the last one. So these are all possible permutations of the objects apple, pear, and grape. Some notation for how we would talk about or write down permutations. The first one I want to talk about is one-line notation. And one-line notation is just the ordering. That's all you're writing down. So the examples here, I'm using letters to stand for the words. Apple, banana, grape, pear. That's the first bullet point there. Another possible permutation of these four fruits would be grape, apple, pear, banana. Another one would be banana, apple, grape, pear. And when you write it in this way, it's one row of data, it's one row notation or one line notation. So one question I have for you is, could you think of all the permutations of these four fruits? Apple, banana, pear, and grape. There are 24 in total, and there were only 4 on the previous slide. So could you find them all? One thing to keep in mind when you're trying to list permutations is that you can't have repeats and you can't leave things out. So GAPA would not be a permutation of ABGP. And one way to think about it is like shuffling a deck of cards. You can reorder the cards, but you're not going to throw any away, and there isn't going to be the same card twice. In preparing for our next notation for permutations, we're going to do an abstraction first where we just think about numbers. So we could have fruits, cars, people, really any objects that you want to permute or reorder. But what we're going to do is abstract them by numbering them. So instead of thinking about apple, banana, pear, grape, we'll think about thing number 1, thing number 2, thing number 3. And one helpful reason we might do this is that numbers have a natural order. 1, 2, 3, 4. 1 should come first, 2 should come second, and so on. So here are some of our fruit permutations, but now written as numbers. Instead of letting A stand for apple, 1 stands for apple, 2 stands for banana, 3 stands for grape, and so on. So this first permutation, 1, 4, 3, or 1, 2, 4, 3, we're saying item 1 goes first because the 1 is first. Item 2 goes second because the 2 is second. Item 4 goes third because the 4 comes third. And then item 3 goes fourth because 3 is in the 4th position, or it's the 4th number written there. The one on the bottom, you might think of as 2 is in the 1st position. Item 3 comes second because it's in the 2nd position. Item 4 comes third because it's in the 3rd position. Item 1 comes 4th because it's in the 4th position. And why am I saying it like this? It's because that's what two-line notation tells you. The first row is always just going to be the numbers in order, 1, 2, 3, 4, 5. And then the second row is that ordering, that one-line notation. Which one comes first, which one comes second, which one comes third. And so, if we think about the one-line permutation, 3, 4, 2, 6, 5, 1, if I want to put that in two-line notation, the 3 comes first, so 3 goes under the number 1. The 4 comes second, so it goes under the number 2. The 2 goes third, so it goes under the number 3. The 6 is fourth, so it goes under the number 4. 5 is fifth, so it goes under the number 5. And 1 is sixth, so the 1 goes under the number 6. The top row is always in order, and the bottom row is our one-line permutation. And so if we want to go back and forth between one-line and two-line notations, here I have the ordering 4, 3, 2, 1 in one-row notation. And to put it in two-row notation, what's the difference? Well, I just add the numbers 1, 2, 3, 4 in order to the top. So 4, 3, 2, 1 becomes 4, 3, 2, 1 in the bottom row of two-row notation. If I want to go in the other direction, if I start with something in two-row notation and I want to write it in one-row notation, well, one-row notation is just the bottom row. So I chop off the top, and this two-row notation permutation becomes 2, 5, 1, 3, 4 in one-row notation because you just take the bottom row. So that's how we get back and forth between one row or one-line notation, which is just the ordering of the numbers, and two-row notation, which emphasizes the position. In the first position, we have the number 4. In the second position, we have the number 3. In the third position, we have the number 2. In the fourth position, we have the number 1.